Let's state some theory. We'll start with a major one. If a inverse exists, the matrix equation AX equals B always has a unique solution. Well, to see this, let's say we have this matrix equation. Multiply both sides on the left by A inverse. Over on the left, A inverse times A gives the identity matrix. On the right, we've got A inverse B. It's not always useful to think of them in these terms, but vectors are matrices. An identity matrix times a vector is therefore just that vector. So we solved the equation. If AX equals B has a solution, it has to be this, and this really is a solution. Another theorem. If A is invertible and, no, not and, then so is A inverse, and the inverse of A inverse is A. Two inverses undo each other. Theorem. I've said before, we don't do a lot with the transpose in this class, but there's no harm in stating it. If A is invertible, so is A transpose. And the inverse of A transpose is the transpose of the inverse. Finally, this is an important one. If A and B are invertible, so is A times B. The inverse is the product of the inverses, but be careful, it's the product of the inverses in reverse order. To prove this, just multiply these things together. Let's see. Only should need a line. There we go. AB times B inverse A inverse. Well, the B and the B inverse give you I. Multiplication by I doesn't do anything. And then A times A inverse is I, just as desired. And if you multiplied in the reverse order, you'd get exactly the same result.